This hearing will come to order. Without objection, the chair is authorized to declare a recess at any time. Good morning. Welcome to today's hearing entitled A Review of the National Oceanic and Atmospheric Administration's Fiscal Year 2020 Budget Request. I would like to welcome Dr. Neil Jacobs to the committee and thank him for coming to testify today on the President's budget request for fiscal year 2020 for the National Oceanic and Atmospheric Administration, NOAA. NOAA's mission is to understand and predict changes in climate, weather, oceans, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. NOAA strives to meet this mission through its 6 line offices that collect environmental observations through satellites and specialized marine vessels and aircraft, analyze, store, and disseminate this data, provide weather forecasts and climate predictions, protect our coastal and marine resources, and conduct cutting-edge scientific research. Many Americans utilize NOAA's publicly available data on a daily basis. That is why NOAA's budget request for fiscal year 2020 of $4.5 billion, an almost 18% decrease from the $5.4 billion provided in the fiscal year 2019 enacted budget, is deeply alarming. Every line office within NOAA received net decreases to their top-line budgets, with significant cuts to both NOAA research programs and extramural research grants. Many of our constituents are already dealing with impacts of climate change, such as sea level rise, heavy rainfall, and rising temperatures in both our oceans and atmosphere. The National Climate Assessment, a congressionally mandated report published by the U.S. Global Change Research Program, describes these and other risks and impacts arising from climate change across the United States, in addition to examining the latest climate science. The U.S. Global Change Research Program is supported by funding contributions from the federal member agencies. The increased frequency of severe weather events that are impacting every part of the country is also described in the National Climate Assessment. We must continue to support efforts to enhance both our weather forecasting and climate prediction capabilities, which are based on long-term records of environmental observation. Across-the-board funding cuts endanger NOAA's ability to continue to collect, analyze, store, and disseminate this critical data. In order to sustain this data stream, we must provide robust and consistent funding for data collected by in situ and remote sensing platforms. The U.S. has been the leader in weather forecasting and climate prediction, not only because of our cutting-edge weather models, but also our uninterrupted record of environmental observations and measurements that span decades, which feed our models and help provide better, more accurate forecasts. Additionally, NOAA has seen large improvements in forecasts by focusing on the transition of weather research conducted at line offices, such as the Office for Oceanic and Atmospheric Research, to operations at the National Weather Service. The draconian cuts of over 40% to the Office of Oceanic and Atmospheric Research would include the complete elimination of NOAA's portion of funding for the National Climate Assessment. These funding cuts would also significantly reduce both intramural and extramural research and slow down the critical research to operations transition. Stakeholders in decision-making roles at state and local levels, including emergency managers, utilize many of the products and services developed across NOAA. When Hurricane Harvey hit my district in 2017, the National Hurricane Center provided direct support to on-the-ground emergency managers and to other decision makers in Houston and across Texas and Louisiana. The National Weather Service also issued its first ever storm surge watches and warnings during Harvey. These storm surge watches and warnings had been under development over the past several years. It's important to note that there were no storm surge-related deaths from Hurricane Harvey, a Category 4 hurricane. The proposed cuts in this budget to the National Weather Service could negatively impact these existing successful interactions with local stakeholders. The benefits of a well-funded NOAA are clear, which is why I am concerned that the widespread cuts proposed in this budget will impact NOAA's ability to meet its mission. Consistent and reliable funding is required to make significant improvements to our weather and climate models, which can be decades in the making, and ensure continuous collection of environmental observations. I'm glad to know that Congress will have the final say on the budgets of federal agencies so that we can ensure that NOAA can continue to meet its critical mission by providing robust funding to an agency that touches the lives of every American on a daily basis. I hope today's discussion will shed some light on how this budget will help support NOAA's long-term priorities. I look forward to a productive discussion with Dr. Jacobs to better understand the administration's justification for its proposed fiscal year 2020 budget for NOAA. Thank you. The chair now recognizes Ranking Member Marshall for an opening statement.
Thank you, Chairwoman Fletcher, for holding this hearing today. It's important that we, as members of Congress, remember it's the responsibility of Congress to vet budget requests, hear from the relevant agency leaders, and make the final decision on funding levels. I also want to add my thanks to Dr. Neil Jacobs for being here today and for his continued service. Coming from the private sector, Dr. Jacobs brings a unique and valuable perspective to NOAA. On top of that, he's graciously taken on the responsibility of being the acting head of NOAA, performing the duties of Undersecretary of Commerce for Oceans and Atmosphere. NOAA has a wide-ranging mission from fisheries management to atmospheric observation. Their products and services have a tremendous economic impact and affect more than 1/3 of America's gross domestic product. As we've heard, the President's budget request for NOAA is $5.4 billion, an 18% decrease from last year's enacted funding. Like all other agencies and departments, NOAA was forced to make tough decisions. But the budget request reflects an attempt to be more efficient in its delivery of services in a constrained budgetary environment. One area I'm pleased to see prioritized is NOAA's research in improving forecasting. America's leadership has slipped in severe weather forecasting, and European weather models routinely predict America's weather better than we can. Critical weather data is a lifeline for many of my constituents that make their living in the agriculture industry. This spring, NOAA's National Severe Storms Laboratory will join with several partners in the environmental profiling and initiation of convection, or EPIC, field project. I'm particularly interested to hear how this project, authorized by this committee last Congress and supported in the President's budget proposal, could have an impact on agriculture and production. I do have some modest concerns about the growth of NOAA's satellite division, the National Environmental Satellite Data Information Services, or NESDIS. At $1.4 billion, or roughly 33% of NOAA's total R&D budget, it's the largest and highest funded area. Not too long ago, in 2008, the satellite budget came in at under $1 billion. Let me say, I do think this increase is warranted, as NESDIS provides critical data and services, but we must ensure the office is equipped to handle this booming growth and use all resources in the most efficient way. NOAA is a mission-oriented agency, and this committee supports these core priorities. We face fiscal constraints that force us to make difficult choices about our science and technology services. I believe that this committee, regardless of a political affiliation, should always support NOAA's desire to emphasize protecting life and property. Thank you, and I yield back.
Thank you, Mr. Marshall. The chair now recognizes the chairwoman of the full committee, Ms. Johnson, for 5 minutes.
Thank you very much, Chair Fletcher, and good morning, everyone. I'd like also to welcome Dr. Jacobs and thank him for being here today to testify on NOAA's fiscal year 2020 budget request. For decades, NOAA's research and services have played a critical role in protecting American lives through accurate weather forecasting and climate prediction, improving our environmental knowledge and stewardship, and supporting a thriving United States economy. It seems obvious to say that the NOAA budget should reflect its mission and ensure NOAA can fulfill its obligations to the American people. NOAA's mission is to understand and predict changes in climate, weather, oceans, and coast, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. Yet NOAA's budget request for fiscal year 2020 is $1 billion lower than its current budget, which is an 18% reduction. These cuts are felt across nearly every program and activity across the agency. This budget would also terminate approximately 547 civilian positions. How will NOAA deliver on its mission with these drastic cuts? We don't have time to go into every detail, so I'd like to use part of my time to highlight some of the greatest concerns. The first is with NOAA's delivery on climate research. Climate change is real and happening right now. Rising temperatures and sea levels and changes in ocean chemistry and ecosystems pose a real threat to public health. These climate impacts also affect the management of our fisheries and coast and the overall resiliency of our communities to extreme weather events. NOAA's activities, tools, and services are central to our ability to understand, to adapt to, and mitigate the impacts of a changing climate. As climate and severe weather events increase in frequency and intensity, so do the costs to human lives and the economy. In 2017, a record-breaking year, the U.S. had 16 weather and climate events that each cost at least $1 billion and a total cost of $300 billion and 362 fatalities. This budget proposes to cut almost $500 million from its climate laboratories and cooperatives, institutes, and nearly dismantles NOAA's Climate Program Office. How will this impact the ability of communities across the United States to prepare for and respond to climate change and severe weather? It also proposes to eliminate the agency's funding for the National Climate Assessments. These assessments represent years of work and extensive review. In our first full committee hearing on the state of climate science, we heard from experts who contributed to the fourth National Climate Assessment. What does it mean when the leading federal agency studying the climate drops out of the main federal report on climate change? I look forward to hearing from Dr. Jacobs on how NOAA intends to continue working on this congressionally mandated report without any dedicated funding for it. I recognize that Dr. Jacobs was given a tough budget proposal from the administration and had to make some difficult decisions. But we need to think about the lives at risk and the potential economic and environmental harm of such a reduced budget. I thank you, Madam Chair, and yield back.
Thank you, Chairwoman Johnson. The chair now recognizes Ranking Member of the full committee, Mr. Lucas, for an opening statement.
Thank you, Chairwoman Fletcher, for holding this hearing on NOAA's FY20 budget request. NOAA has a broad array of responsibilities, ranging from weather forecasting and climate prediction to ocean and atmospheric observation. NOAA's work benefits America's farmers, ranchers, coastal communities, disaster personnel, land use planners, weather forecasters, and Americans across the country. NOAA's research and publicly available data has an immense economic impact. The President's budget proposal for NOAA reflects difficult decisions made across the federal government. I appreciate the effort of the administration to submit a proposal that emphasizes NOAA's core priorities, principally protecting life and property. Beyond these basic functions, NOAA is prioritizing other areas within its jurisdiction, including improving agency efficiencies for satellite management, maximizing the economic contributions of our coastal and marine resources, and reducing the impacts of extreme weather incidents. We have heard concerns about some of the proposed cuts included in this request. I would remind my colleagues that the President's budget request is just a starting point for our discussions, and we're here today to learn more about how to best prioritize NOAA's resources. It's also important to note that in recent years, Congress has decided to fund NOAA at a higher level than the President's budget request. Many of our constituents are interested in NOAA's work, particularly the National Weather Service. Oklahoma is home to cutting-edge research on weather forecasting and climate prediction. Last month, I had the opportunity to tour the University of Oklahoma and Oklahoma State to learn about the research being conducted in partnership with NOAA. I also toured the National Weather Center in Oklahoma and heard from many dedicated researchers working to improve our weather forecasting abilities. There was one unmistakable conclusion from this trip. The work done by the National Weather Service is very important and must be a focus of this committee's work in this Congress. As a rancher, and in all fairness, my wife prefers to refer to me as a farmer, she's the rancher, I can tell you that accurate weather prediction is critical for our nation's agricultural producers. So I have a keen interest in the committee's work to help improve weather forecasting. During the 115th Congress, this committee passed my Weather Research and Forecasting Innovation Act of 2017, which was subsequently passed into law and is being implemented by Noaa. I look forward to hearing about Noaa's continued implementation efforts for this act. I want to thank Dr. Jacobs for appearing before the subcommittee today. His enthusiasm for his work is apparent, and he brings a unique perspective to Noaa's leadership, thanks to his extensive experience in the private sector. Madam Chairwoman, I yield back the balance of my time.
Thank you, Mr. Lucas. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witness. Dr. Neil Jacobs was confirmed as the Assistant Secretary of Commerce for Environmental Observation and Prediction in February 2018. He has been performing the duties of Undersecretary of Commerce for Oceans and Atmosphere since February 2019. Prior to joining NOAA, Dr. Jacobs was the Chief Atmospheric Scientist at Panasonic Avionics Corporation. He was also previously the chair of the American Meteorological Society's Forecast Improvement Group and served on the World Meteorological Organization's aircraft-based observing team. Dr. Jacobs has a bachelor's degree in mathematics and physics from the University of South Carolina and a master's and doctoral degree in atmospheric science from North Carolina State University. Dr. Jacobs, you will have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you've completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question you. Dr. Jacobs, you may begin your testimony.
Chairwoman Fletcher, Ranking Member, and members of the committee, thank you for the opportunity to testify today. The President's FY20 budget request for NOAA is $111 million above the FY19 request and emphasizes core programs while making targeted investments, which we believe will produce a substantial return for the American taxpayer. Accelerating advancements in global modeling program is a top priority. While there have been many achievements in 2018, problems exist with the current structure of weather research to operations. The internal and external strategy is fractured, the computing procurement process is cumbersome, and the funding process disincentivizes collaboration. The FY20 request addresses many of these challenges through the creation of the Earth Prediction Innovation Center, or EPIC. Based on the Weather Research and Forecast Innovation Act of 2017 and recently authorized in the National Integrated Drought Information System Reauthorization Act of 2018, EPIC will serve as a hub for building and maintaining a true community model. EPIC's innovative structure will link scientists and software engineers in academia, private industry, and partner agencies with research, development, and operational activities inside of NOAA. EPIC will significantly enhance our ability to access external expertise, reestablishing preeminence of U.S. forecast model skill, and improving our ability to provide accurate watches and warnings. The NOAA Satellite Observing System Architecture Study, or NSOSA, which was completed in 2017, analyzed various approaches to better meet mission requirements with greater flexibility, responsiveness, and incorporating evolving technologies. Congress recognized the importance of NSOSA codifying the program in the NIDIS Reauthorization Act of 2018. The budget initiates NSOSA implementation with investments to evaluate innovative space-based solutions and partnerships, including $12.3 million for joint venture partnerships and hosted payloads on geostationary and polar orbits. It also continues the importance of the Commercial Weather Data Pilot Program, as well as $5 million for the option to purchase data after successful testing. This budget makes necessary investments for strong coastal communities and economies, and includes an increase in $2.3 million for regional fishery management councils to analyze and remove outdated or ineffective regulations. To help level the playing field for U.S. commercial fishermen in the global seafood marketplace, an additional $1.6 million is requested to enforce the Seafood Import Monitoring Program and prevent the importation of seafood caught using illegal fishing practices. Finally, the budget includes an increase of $3.6 million to support aquaculture by assisting industry with regulatory compliance, conducted research, and ensured American farmed fish are safe and sustainable. Executive Order 13840 established a national ocean policy focused on providing tools to coastal communities to substantially manage their offshore waters. The budget includes an additional $4 million for ocean data platforms, building on innovative tools developed by NOAA to improve siting of offshore activities. NOAA has made great strides in the past 2 years to reduce the amount of time needed for environmental review. The time to complete formal and informal Endangered Species Act consultations was reduced by over 22% and 65% respectively. Incidental harassment authorizations under the Marine Mammal Protection Act have been reduced by 25%. The FY20 budget builds on this success by providing an additional $3 million to further reduce the timeline for consultations and permits. Other sections in the blue economy that this budget addresses include marine transportation through additional precision navigation data, efforts to reduce marine debris accelerating economic benefits of the new and expanded marine sanctuaries, and reducing the backlog of natural resource damage assessment cases. Finally, this budget includes $5 million for the National Oceanographic Partnership Program. We intend to use these funds to leverage investments from other federal agencies, private industry, philanthropic organizations that have shared interest in advancing ocean research. These funds can be used for a variety of partnerships ranging from ocean exploration to new technology to detect and protect marine mammals. NOAA's services touch every American every day. I believe this budget request meets NOAA's core mission of protecting lives and property while also positioning the agency to be more effective in moving forward. Thank you again for the opportunity to testify today. I would be pleased to answer any questions you may have.
Thank you, Dr. Jacobs. At this point, we will begin our first round of questions, and I will recognize myself for 5 minutes. I have 2 general categories of questions, so I'm going to try to move through them fairly quickly, Dr. Jacobs. The first is on the impact of budget requests to NOAA's mission and global leadership. Despite NOAA's stated priorities of reducing the impacts of extreme weather and water events, maximizing the economic contributions of ocean and coastal resources, and advancing space innovation, the President's budget for fiscal year 2020 requests a total of $4.5 billion for NOAA, which is 18% below the fiscal year 2019 enacted budget, as we heard previously. So a few questions, if you could touch on these. How does NOAA intend to meet its mission and priorities with reduced funding for every single line office of the agency? How can the U.S. remain a global leader in weather forecasting, climate prediction, and oceanic and atmospheric research, given these significant cuts across the board at NOAA? And how will NOAA continue to support robust private sector and academic research in the ocean and atmospheric sciences with reduced funding for extramural grants throughout the agency?
Well, the FY20 request, just going across the board, the climate is 88 million, oceans are 98 million, and weather is 110. I would like to say that a lot of the research we're doing on the weather forecasting aspect, we're transitioning to a unified forecasting system, which is also, the weather model is going to double as a dynamic core for our climate model. So while we're funding the research for the weather model, that's actually going to benefit the dynamic climate modeling system. On the weather forecasting side, currently the U.S. is not considered the leader. We're actually lagging the European Center, and that was the basis for the Earth Prediction Innovation Center, which actually sort of answers your last question. So the idea in this center would be to harness external development through universities and private industry and give developers for the model code a cloud-based sandbox, so to speak, to do collaborative model development. So it would harness a lot of what's in private industry as well. And then on the ocean side, we have the National Oceanographic Partnership Program, which would also leverage private investment to help further some of our research.
Thank you. And switching gears, the other topic that I want to cover with you with the remainder of my time is reductions in funding for Hurricane Forecast Improvement Project. This fiscal year 2020 budget request would slow the development of the Next Generation Global Prediction System and Hurricane Forecast Improvement Project by reducing research grants for the collaborative research activities and NOAA's test beds. The budget request notes that this $2.1 million reduction may be offset by the additional funding for the Earth Prediction Innovation Center, but it is not clear whether that will be the case. Hurricane Harvey inflicted $125 billion of damage in Houston and Southeast Texas, and hurricanes are predicted to increase in frequency and intensity with the changing climate. Timely and accurate hurricane forecasting will be essential to protecting life and property in the face of these oncoming disasters. Dr. Jacobs, how can NOAA ensure that our communities are equipped with the best possible hurricane forecasts, given this funding cut to the Hurricane Forecast Improvement Project and the rising threats from more intense and more frequent storms?
So on the modeling side, I'll break it down into three sections to improve the hurricane forecasting. We have model code development, which we're doing through EPIC now. That includes the finite volume cube sphere, which is our global model that we use for hurricane track. It also is ultimately going to be the model that we transition from the WRF model, which is our hurricane intensity model, to the FV3. I'd also like to mention the storm surge forecasting. This is something that's really critical. A lot of people don't realize when they think of hurricanes, they think about high winds, but it's actually the water that is responsible for the deaths of most individuals. We have a very sophisticated storm surge forecasting model that we're working on that's actually funded through the National Weather Service. Even though it would be research, it's funded and it's used operationally in issuing watches and warnings. The next step, so going back to the observation side, we are acquiring more ship observations. We're outfitting an acquisition of a second backup capability with the G4 aircraft. We'll have both of our P3 hurricane hunters in operation this year. The thing that I'd really like to highlight is the national water model. So one of the things that we haven't done yet, but we're working on, and we saw this in Harvey, and we saw it in Florence, and we'll likely see it again, is the integration between the inland flooding and the storm surge. So one of the things a lot of individuals don't realize is, particularly in the case of Florence, when these storms produce a tremendous amount of rainfall, that rain has to exit the coast. And if there's onshore sustained winds from a storm surge, the water just piles up. So we're in the process of coupling our storm surge models with the national water model. That's something that we're going to be working on with the USGS and the stream gauge data that they provide. And while it won't be operational this year, I think that that's really going to show some improvements in the future.
Thank you, Dr. Jacobs, and I see that my time has expired, so I'll now recognize Ranking Member Marshall for 5 minutes.
Thank you, Chairwoman, again. Dr. Jacobs, we have a saying back home in Kansas that if you don't like the weather, just wait an hour. And my question is, how does your new innovation, the Earth Prediction Innovation Center, going to help my constituents, my farmers more particularly? And just to give you one example, people think of agriculture and weather as all it matters if it's rain or not, but I'll take something as simple as alfalfa. You cut the alfalfa, there's probably about an hour or two each day that the humidity is maximum for locking in all the protein in those leaves. If you wait too long, it dries out. If you wait too long beyond that, that afternoon thunderstorm is going to pop up. And if you do it too soon, there's too much moisture in it. So how's this EPIC going to impact my farmers?
There's a couple different ways. So starting from the longer range and coming back into the shorter range, we're actually looking at seasonal to subseasonal forecasting with the dynamic climate models, as well as some statistical models. I think for long-range decisions in agriculture, that's going to be very helpful. On the shorter range, with the convective allowing models, we're going to be looking at doing probabilistic forecasting. Right now, the capability to predict a tornado is not within the science, but we can predict the probability of a tornado. And so we have a couple of things we're working on here. One of them is what we call warn-on forecast, where instead of actually waiting to see when the tornado appears on radar, we actually have the capability in the forecasting to simulate rotation in the thunderstorms and issue warnings before the tornadoes appear on the radar. That can extend the lead time slightly. The other thing is social sciences. So one of the things that we learned in some of the social science research was that humans aren't necessarily rational, and we have to think really smart about how we message the warning. If we give someone enough lead time to make a decision, but on the other hand, if we give them a lot of lead time, they might not make the same decision. So the last step of this is actually interfacing with the emergency management community and also looking at the social science aspect of it. Your statement about the moisture in the crops is interesting and also actually ties into the land surface modeling. So one of the things we've noticed with the land surface modeling is that the transpiration in plants over fields versus plowed fields can actually induce convective activity. So this is something that we're looking at, but it's at a very high resolution, and some of the satellite data we collect is critical to this.
Okay, maybe we'll move on here. I'm sure we could continue to have that discussion. There's more to talk about. But next, as I understand, NOAA is fast approaching the end of its current contract for its weather and climate operational supercomputing system, WCOSS. I'm sure you've got a pronunciation for that. A priority of this administration, and we'll need to enter a new contract. Can you explain the importance of this system for NOAA's mission? And are there any limitations in how NOAA must enter new contracts, such as the ability to enter multi-year contracts to reduce costs?
So WCOS is critical to our mission. This is our high-performance computing where we run all of our operational models. The procurement process is a little bit tricky. Typically, we will go through a third-party vendor to do the procurement, but when they do the procurement, they actually acquire the hardware from the actual vendors. And so what happens is when this procurement agent goes to acquire the hardware from the vendors, they don't want to get stuck holding the bills. So they will actually ask us to put what's called a cancellation liability fee, essentially money in escrow to protect them in the very rare chance we might back out of the contract. What happens is we have to essentially park $50 million in escrow to protect them from us backing out. That $50 million is $50 million less of HPC that we actually can use for computing resources. And if we're on a 3-year rolling renewal of the lease cycle, we'll almost have to have this money parked indefinitely to protect us from that.
Okay. Thank you so much. I'll yield back the remainder of my time.
Thank you very much. I will now recognize Chairwoman Johnson for 5 minutes.
Thank you very much. Dr. Jacobs, you might know that I chaired a hearing on NASA's fiscal year 2020 budget request earlier this month. And one of the members asked about FCC's 5G spectrum auction at the 24 gigahertz band. And Administrator Bridenstine was very clear in saying that potential bleed over into weather data channels could take us back to the 1970s in terms of weather forecast. He mentioned a study that NASA did in conjunction with NOAA that determined there's very high probability that we're going to lose a lot of data. Do you have any reaction to Mr. Bridenstine's response, and what is NOAA's current state of play on the issue, and what are we doing to mitigate any potential interference?
So the potential interference in the 24 gigahertz spectrum is essentially out-of-bounds emission from the adjacent spectrum. Now, we do passive water vapor sensing from our polar orbiting satellites, and if the out-of-bounds emission thresholds are too large, essentially these instruments will just blind our satellites and we won't be able to detect water vapor. We are currently, so our subject matter experts are looking at the proposed minus 20 decibel watts of out-of-bound emission proposed by the FCC. Our subject matter experts, along with NASA subject matter experts and subject matter experts from the FCC, are collectively collaborating on a study. They're actively doing that right now. The results of that study will be decided upon on May 15th, whereby we will ultimately make a decision on what the acceptable out-of-bounds emissions is to protect future spectrum. Right now, the number is in flux because there's a lot of assumptions that go into the study, but we should have a definitive answer in the next couple of weeks.
If this budget is enacted, would Noaa continue to participate in the NCA process in the absence of the dedicated funding?
Absolutely. So this won't limit our participation in NCA 5 at all. There's several other agencies. I would like to note that the NCA budget for NCA 1, 2, and 3 was originally produced without a budget line. So I don't see this impacting our ability to provide expertise and data for NCA 5 at all.
Okay. With the proposed budget, what do you predict would be the impacts of which you would have to face?
Well, a lot of the cuts were made to external research grants in favor of maintaining core capabilities so that we wouldn't degrade our ability to deliver on our mission. So external research, as it pertains to universities and such, would likely take the largest hit. Maintaining our core capabilities is obviously a top priority, and the core capabilities within this budget will be maintained.
Mm-hmm. Now, this budget proposes to aggressively cut grants as it relates to students and graduate students, for which really helps to create your manpower. How do you plan to address that?
Well, there's a lot of opportunities through external partnerships, through public-private partnerships, as well as the public-private partnerships collaborating with industry and then using a lot of industry funding to drive academic research. So that's the crux of EPIC, the Earth Prediction Innovation Center, and also the backbone of NOP, the National Oceanographic Partnership Program.
Mm-hmm. You have knowledge of this industry spending coming about?
I do. So when I was at Panasonic, I actually did a lot of collaborative model development with the Weather Service. We also, through industry, funded 5 different universities, including PIs and postdocs, to do research. Granted, we had a financial interest as a private company, but the ultimate benefiter was the Weather Service in helping improve some of their forecast models, as well as different PIs at universities and their students who wanted to get research publications out.
Thank you. My time's expired.
Thank you, Chairwoman Johnson. I'll now recognize Ranking Member Lucas for 5 minutes.
Thank you, Chairwoman. Dr. Jacobs, the Weather Research and Forecasting Innovation Act of 2017, which I sponsored along with many of my colleagues here today, prioritized commercial weather data to improve our forecast skills. I understand NOAA is continuing the commercial weather data pilot program. Could you discuss with us for a bit what is the status of the program, and does NOAA plan to buy this data after it's tested?
Yes, so thank you very much for the Weather Research and Forecast Innovation Act, as well as the NIDIS reauthorization. The Weather Data Pilot Program, what we've learned through testing is that the GPSRO data that we were collecting adds value. We haven't quantified exactly how much, but we know that it adds enough value to make sense to enter into a contract to acquire the data. So we'll be transitioning that from a pilot program to an actual data acquisition program. The pilot program will still exist, and we're using that to explore space-based data sets beyond GPSRO, for example, possibly hyperspectral sounders or instruments like that.
Doctor, during my tour of the University of Oklahoma and Oklahoma State, I heard from several of my constituents that we are potentially on the cusp of a breakthrough in our ability to forecast short and long-term weather. And I know this is a topic my colleagues have discussed also, but do you agree with this sentiment? And what steps can this committee take to help assist NOAA and the private partners in this endeavor?
We are very close to making some major leaps forward. The primary difference between us and the European Center, which is the modeling agency that we're always compared to, is the data assimilation of the model. So while I just spoke earlier on the upgrade to the dynamic core, We haven't upgraded the data assimilation system yet. We're expecting that is probably 1.5 to 2 years away, but we have to upgrade a lot of the infrastructure and architecture around the software, including the dynamic core, before we upgrade the data assimilation system. That's where I think you're going to see the biggest leap forward in improvement in forecast skill. In addition to that, transitioning all of the code to cloud-based architecture. One of the biggest hurdles in harnessing external collaborator development is they don't have login credentials to our machines because of various security requirements. So the best way to solve the problem was to move the model code to a compute architecture that they had access to external to Noaa. And I think once that transition is finished, you'll see development rapidly occur.
Thank you, Doctor. One last question. And thinking about the chairwoman's questions about the spectrum and frequency. This committee has a long history of supporting investments in NOAA's satellite systems. If the FCC auctions spectrum that limits the utility of these systems is worth, if the FCC is going to auction off parts of the spectrum that affect the utility systems, is it worth continuing to fund these billion-dollar satellites, Doctor?
Well, we'll have to wait until the final number is decided on the out-of-bounds emissions limits, and then we can actually use that number to determine how much of the data will be impacted. And once we determine how much data is impacted, then we can do an actual assessment on whether or not we can meet the mission requirements. If it's impacted such that we can't meet the mission requirements, then it would be prudent to rethink the investments in future polar orbiting satellites.
And that would be a shame if we lost all those billions of dollars in investment, and that I would hope the other areas of the federal government are paying as close attention to this issue as you are, Doctor. Thank you very much. Yield back the balance of my time, Chairwoman.
Thank you very much, Mr. Lucas. I will now recognize Mr. Tonko for 5 minutes.
Thank you, Chairwoman Fletcher, and thank you, Dr. Jacobs, for joining us today. As the global climate crisis continues to press devastation beyond our shores and into our communities, countless businesses, local news stations, and millions of Americans depend upon scientific forecasting from 4,200 National Weather Service employees to stay safe. With that in mind, I have some major concerns about National Weather Service understaffing. In its fiscal year 2019 budget proposal, the agency sought to eliminate 355 positions in the NWS, including 248 frontline forecasters, 20% of all forecasters in the NWS's 122 forecast offices nationwide. Congress soundly rejected these proposed reductions, and the House Appropriations Committees directed the National Weather Service to continue to hire in 2019 and to have additional FTEs on board by the end of the fiscal year. However, according to reports the agency has provided to the National Weather Service Employees Union, the number of FTEs at the NWS is essentially unchanged from the beginning of the fiscal year. There were, in fact, fewer non-supervisory, non-managerial employees at the NWS at the close of pay period 5 in 2019, March 16, 2019, to be specific, than there were when the fiscal year began. Noaa has once again proposed to eliminate some 355 positions in the NWS in its fiscal year 20 budget request. So my question is the NWS intentionally failing to fill vacancies at the NWS in anticipation that Congress will eventually approve this request?
So during the shutdown, so typically this shutdown occurred during the end of the year, across the end of the year. So a lot of times when individuals retire, we will see that happen at the end of December. So prior to the shutdown and resuming after the shutdown, this was the first time since 2011 that the hiring has actually outpaced attrition. We haven't fully gotten back to the number that we recovered from what we saw during the shutdown, but during FY19, the onboard rate right now is roughly 91.5%.
Well, will you be committing to doing the remaining percent?
Yes, we're committed to trying to close that gap, but we're also battling attrition and retirement at the same time.
Right, which is nothing new.
No, that's expected.
Okay. Last year, the agency informed the Appropriations Committee that there were 381 funded vacant positions at the NWS. What other items have to be done, what other forces have to be engaged to experience progress in filling these vacancies? I mean, you described some, but what else are you going to do for that percentage that are yet unfilled?
So when you see the cuts in there, that actually is largely offset by some money that we're going to save by reducing the need to move individuals around. So we just recently implemented what's called GS 5 through 12, which is a career progression path to go from the GS for GS 5 all the way to 12. Typically, historically, a lot of times what would happen is a weather service forecaster, in order to receive a promotion, would have to move from one forecast office to another forecast office. And in many times, we would actually have to pay for that move, in some cases, buy their house. It ended up costing us around $12 to $15 million a year. With the new GS 5 through 12 career progression, we actually will save money.
Has this all been done in consultation with the employees?
Yes, this went through the employees' union.
And what effect has the recent shutdown, you mentioned that shutdown was part of the delay, but what can you describe with more detail what the recent shutdown had as an impact on hiring at the National Weather Service?
Well, like I was speaking to earlier, typically individuals will work through the end of the calendar year. So we see the most retirement right at the end of the year, and so that happened to coincide with the shutdown. So while they were retiring, there was simultaneously a delay in onboarding people. There was not just a delay in the direct hiring, but a delay in the onboarding process. So the people who were actually already hired but not fully onboarded, that process was also delayed, and we're still digging out of that right now.
So what happens if we have a future shutdown, and what impact can we anticipate, or have we learned from that shutdown?
Well, it really depends on when it is during the calendar year. If it happens during the end of the calendar year across the transition, then we'll likely see a fairly large number of retirements that we will be delayed in onboarding new individuals. Once the lapse in appropriation is over.
Madam Chair, I have exhausted my time, so I yield back.
Thank you very much. I'll now recognize Mr. Babin for 5 minutes.
Thank you, Madam Chair. Appreciate it. And Dr. Jacobs, appreciate you being here today as well. Can you please talk a little bit about NOAA's relationship with NASA? Are there opportunities to be more involved in utilizing one another's capabilities in the area of weather forecasting and predictions? And what could these relationships look like down the road?
So NASA, we have a fantastic relationship with NASA. The two agencies are very collaborative and work on a lot of different fronts. I think most people would think of the NOAA-NASA collaboration when it comes to our satellite programs, whether it's the geo-hosted or the joint venture for polar orbiting. We've got some new things that we're working on that front, in addition to the commercial data buys. But on the modeling side, there's a lot of collaborative work that we can do with NASA on this. We're trying to go to a unified forecasting system. So not just NOAA, NASA, but all the different government agencies are working off the same model architecture, so that whenever an agency is doing development work, whether it's NOAA, NASA, DOD, DOE, it all gets bundled into the same framework. A lot of other interesting things we're working on with NASA are the data assimilation. We're looking at observation impacts through their forecast sensitivity to observation tool, which is extremely useful. There's also work we're doing with them, as well as DOE, on looking at GPUs instead of CPUs for different type of processor work as well. In addition to that, exploring cloud compute architecture.
Okay, thank you very much. Also, I represent Southeast Texas, where the chairman had mentioned that we got hit so hard, decimated by Hurricane Harvey almost 2 years ago. We're still in the midst of recovery from this storm. And there's been a couple of severe storms already this year, and it's incredibly important to accurately predict storms and their magnitudes. how accurate is the state of our severe weather forecasting, and do you think that we can do it better?
We absolutely can do it better. There's always room for improvement. Right now, the model that we would typically use for the high-resolution convective forecasting only runs out a day. We rapid cycle that model so it refreshes every hour. There's a lot of work to be done on the physics in the model as well as observing system capability. Once we eventually transition to a global model, a lot of our convective forecast will be driven by data that we collect over the Pacific Ocean, because the longer we predict out, the further west we have to do observations. So there's work to be done on the observing system side as well as the modeling side. And in parallel to that, utilizing HPC better, because as we go to higher resolutions, it requires more and more compute resources.
Okay, and then how do you plan to incorporate emerging commercial capabilities, especially in space weather area, into NOAA's long-range planning?
So when it comes to commercial space-based observing systems, essentially what we would do is look at the impact of the data in the models, very much like we did with the GPSRO data, and determine how much value it adds to the forecasting skill. That's a little bit of work on our part too, because we have to make sure that the model is accepting of the data and can extract value out of it, assuming that the commercial market to produce space-based weather observations is seeing value in selling the data to us. It's, in my mind, a more viable path to acquire the data. We can do it for less money, and as long as they meet the thresholds that we set for quality and reliability, I think it's a definite path forward.
Okay, and then lastly, what suggestions do you have for us members of Congress to help you maximize the best resources provided to NOAA?
Well, to maximize the best resources on the compute side, the cancellation liability fee is obviously a large concern, because that's $50 million extra HPC that we could be using that we're just sticking the money in an account. Transitioning to cloud-based architecture is, I believe, the future, because it solves a bottleneck of compute resources on the research side. And there will be some upfront work to transition that code over, and then continuing to support scientists both on the modeling side and the software engineering side, both internal and external to NOAA. That's where I think we'll see the biggest improvements in forecasting.
Okay, thank you very much, Doctor, and I yield back. My time's expired.
Thank you. I'll now recognize Dr. Baird for 5 minutes.
Thank you, Madam Chair, and Dr. Jacobs. We really appreciate you being here today. My district in home is home to Purdue University, which administers the Illinois-Indiana Sea Grant College Program, and that's in partnership with the University of Illinois. And this Sea Grant is funded through NOAA, and that works on aquatic invasive species and their control, pollution prevention, and economic opportunity. It also monitors weather and lake conditions using 2 buoys, which I understand they have their own Twitter account. Is that correct? But anyway, out in Lake Michigan, where real-time data about wind speed, lake temperatures, and wave height is collected and sent to NOAA. So my question, Dr. Jacobs, is how does NOAA strike a budget balance between the internal research that stays with NOAA and the extramural research that goes out to NOAA's private and academic partners?
So in the tough budget situation we're in, we really had to prioritize maintaining our core capabilities of protecting life and property. And while the Sea Grant program is a fantastic program, I'm a huge supporter of it. We have Sea Grants, Canals Fellows on our staff. it was one of the things that we ended up having to cut just to maintain our core capabilities.
Then my second question in that same area, historically, has more extramural research money been provided to universities by NOAA's research office or by their weather service?
Typically, the money for the research side as well as the cooperative institutes runs through the research side, not the forecast side. So the weather service budget was relatively flat. It was the research side.
Thank you. My next question then deals with the National Integrated Drought Information System, and I think that was reauthorized in December. So, and Congressman Marshall made reference to the impact of EPIC on agriculture. So my question deals with, because we have a lot of agriculture in my district, my question deals with how is this interagency partnership assisting farmers and the agricultural industry across the country?
So EPIC, while originally designed to support NOAA's mission, will actually be the transition for model development produced by NASA, DOD, DOE, and other agencies. So there's going to be a lot of development work running through EPIC by other agencies that will ultimately help the medium to long-range forecast. So the dynamic model that we're looking at for global forecasting runs out 15 days. Then beyond that, we have two methods for doing seasonal and to sub-seasonal forecasting. One is a dynamic model and associated ensembles, as well as statistical models, which look at the dynamical model output and then derive statistical forecast running out 9 months. We're looking to extend those possibly beyond 18 months.
Thank you. Could you elaborate, though, on the how the National Integrated Drought Information System relates?
The NIDIS reauthorization supports, in there was the authorization of EPIC, but also supporting the seasonal to sub-seasonal forecasting as well. And that longer range forecasting is what the agricultural community is primarily interested in.
Thank you, Dr. Jacobs, and I yield back my time.
Thank you, Dr. Baird. Before we bring the hearing to a close, I want to thank Dr. Jacobs for testifying before the committee today. The record will remain open for 2 weeks for additional statements from the members. For any additional questions, the committee may ask our witness. The witness is excused, and the hearing is now adjourned.